Alright. Let's do this one. Okay. T cubed minus 3t squared. That's our function. Okay. And then we've got, I think there's 6 questions that I want to answer. 3 on this slide. I want to put 3 on the next one.
Lindsay, you know that pyramid thing that you showed us?
The ones and two?
Yeah.
Yep. Mm-hmm.
That is so amazingly revolutionary that I was amazed at how it worked.
How it worked?
Yeah.
And it lets you, and really you only got to know like the first 3 lines, you know, really the first,
and if you,
the
if
second
you wanted
and
to,
third
you just
one.
keep making it. But
Mhm.
how does that work?
Mm-hmm. How does it work? Okay, so
I know.
So, if I have something to the 0 power, right, so this is for expanding binomials, okay? So if I have something to the 0 power, anything to the 0 power is going to be 1, right? Okay? If I have something to the first power, that's going to be whatever plus whatever, right? In this case, t plus h is what we've been using that for, okay? T plus h to the first power is t plus h. Okay? If I take it to the second power, then that's going to be that. Okay? And I got that 2 from adding those 2 together. Okay? So what I'm saying here is t plus h quantity squared is t squared plus 2th plus h squared. Because I take the left one and I start here, and so then this would be t squared. Then I go to t. So the left one I work left to right on. The right one I work right to left on. Starting with this exponent and getting all the way down to 0. Okay? And then third power would be 1, add those 2 together is 3, add those 2 together is 3, and then 1. You always have 1s on the outside. Okay? So then this would be t cubed plus 3t squared h plus 3th squared plus h cubed. 6, 4, 1. Yep. And you can keep going and you can do that. And it works for numbers too. So like we did t plus h up there. So if I did y plus 3 quantity cubed, right? So that would be y cubed plus 3 times, so then this would be, here, let me put it in purple here. So this would be y cubed 3 to the 0, y squared 3 to the first, y 3 to the second, y to the 0, 3 cubed. Right? Okay. So this is going to be 3 times y squared times 3. So that's going to be 9y squared. This one's going to be 3 times y times 3 squared. 3 squared is 9 times 3 is 27. And then that one's just going to be 3 cubed, which is 27. Yep. Yep. Okay. Now, knowing that, shabam. Make it happen. So for the first one, we're looking for f of 6, which is going to be 6 cubed minus 3 times 6 squared, which is, what's that, 216 minus 108. Oops, wrong color. So it's 108 meters away, 6 seconds later. Yep. Okay. A rock, so this is going to be of 5 minus f of 3 over 5 minus 3. So that's what? What's f of 5? 125 minus 75 is 50. Uh, 0, right? 27, 27? All over 2. So that's going to be 50 divided by 2 is 25 meters per second. Yes? All right, now the big boy. So my IROC, or f prime of t, my first derivative, is going to be the limit as h approaches 0 of f of t plus h minus f of t divided by h. Right? It was t cubed minus 3t squared. Was our function? Yep. Okay. Just so we have it. All right. So that's going to be the limit as h approaches 0 of, so that's going to be t plus h quantity cubed minus 3 times t plus h quantity squared minus t cubed minus 3t squared all over h. Okay. If we follow the triangle, the Pascal's triangle that we were talking about beforehand, so then that's going to be t cubed plus 3t squared h plus 3th squared plus h cubed minus 3t squared minus 6th minus 3h squared, because t squared plus h quantity squared is t squared plus 2th plus h squared. And all that gets times negative 3, gets me that. Then minus t cubed plus 3t squared. All of that is over h. Now, any non-h term should be gone, right? T cubed minus t cubed minus 3t squared plus 3t squared eliminates both of those, right? And then, missed. And then, so that's going to be the limit as h goes to 0. Now I can divide every term by h. So that's going to be 3t squared from this one, plus 3th there, plus h squared there, minus 6t there, minus 3h there. Yep. Now I don't have a denominator anymore, so now I can send h to 0. When I send h to 0, 1, I get the first derivative function, and 2, any term with an h left in it goes away. So that one goes away, that one goes away, and that one goes away, leaving me just with 3t squared minus 6t as my function. our function was that. Our first derivative was that. Okay? So now what I want you to do is I want you to answer those 3 questions. We'll do the sketch at the very end. Okay? So you just give me the where and stuff. Okay? Go for it. You get there in order to get the flag, you gotta solve the puzzle. Or
that kind of like, I don't know, that kind of ruins like the whole escape aspect.
right.
Maybe you have to solve it when you
Alright, so
I don't know this.
how do I know when the object is stopped? What?
When set the determinant.
Derivative?
Yes, that.
The derivative?
That's
Okay.
what I meant.
So yeah, exactly.
Yeah,
Determinant, that's matrices.
it's Friday.
Okay? So we set 3t squared minus 6t, our speed. We set that one equal to 0. Okay? So I can factor out a 3t. Leaves me with t minus 2. So 3t equals 0. So that's going to give me at t equals 0, it stopped. And at t minus 2. So at t equals 2, it stops. Okay. What's the IROC at 1, 3, and 5? So at 1, it's -3. So 3 times 1 squared minus 6 times 1 is going to be 3 minus 6. So that's going to be -3 meters per second. Okay. And then we said at 3, it's going to be 3 times 3 squared minus 6 times 3. So that's what, 27 minus 18. So that's 9. And at 5, it's going to be 3 times 5 squared minus 6 times 5. That's going to be 75 minus 30. 45 meters per second. So it really kind of stepped on the gas there in between 3 and 5 seconds. Okay? Where is the object when it is stopped? So for this one now, I would have to find f, my position function. Remember, this one is my position. This one is my speed. So I would have to find f of 0. So if I find f of 0, what do I get? 0, right? Cubed minus 3 times 0. Huh? And then I'd have to find f of 2, right? So that's 2 cubed minus 3 times 2 squared. 2 cubed is 8. -4 meters. Okay. All right. So this one tells me at and this one tells me at 2. Now, if I were to sketch both of those functions, okay, I get two distinctive looking things. Okay? So here are those two sketches. So this is my position function. This is my speed function. Okay? So my position function tells me that I start out and I actually go backwards. Right? So if I'm pointed in that direction, I actually start out and I back up and then I rapidly go forward. Okay? Now notice it gives me that position right there at t equals 0. I'm at 0 meters. We found that up here on this top one. Okay? At t equals 2, I'm at -4 meters. We found that one. Okay? Speed-wise, it tells me at 0, I'm not moving. I'm stopped. Now I'm looking for zeros there. Okay? And at 2 seconds, I've stopped. I'm not moving. Okay? And what we'll find, starting on Monday, Tuesday, on the 4-mod day, is that those 2 points correlate. Okay? Here, if I'm looking at the position function, the slope of the tangent line is 0 when I'm stopped. Okay? Slope is negative when I'm going in backwards. Slope is positive if I'm going forward. Okay? All right? You now have more than enough information to finish off worksheet E, okay, which most of you have probably almost already done. Answers are up there if you wanted to check them. Okay.